built a machine learning model to predict the outcome of a very special game happening tonight. So tonight, there's an NFL playoff game between the San Francisco 49ers and the Seattle Seahawks, and everyone has their thoughts and feelings of who's going to win. But instead of arguing back and forth, today we're building a supervised machine learning classifier on this real-world Kaggle dataset. Now, if you've never heard of logistic regression before, it looks at thousands of past games where we know the input, like the weather, what teams were playing, where the game was played, and more. It learns how much each individual input matters when it comes to predicting the outcome of a game. Then, to predict a new game, it multiplies all the inputs by their weights, adds a baseline, and squishes the score into a number between 0 and 1. So the model will not give us an output like, I am 100% sure that the 49ers will win. Instead, it'll say something like, there is about a 76% chance that the Seahawks will win. We're building a model that answers one simple question. Given the betting line before kickoff, what is the probability that the home team wins? So let's break it down. We always begin by importing all of the needed libraries for our project. Today we need NumPy for math, pandas for data, and some tools from scikit-learn to help us run and train our machine learning model. And now it's time to import our data. For this project, we're bringing in two CSV files from the dataset. The first file has historical game data with pre-game betting information like the spread, the over-under details, and who actually won. The second file is a team reference database that lets us convert each team name into a consistent team ID. And this just keeps all of our comparisons very neat and tidy. So we start by loading our data into a data frame and creating standardized identifiers for both the home team and the away team. This matters because the betting file might use team names in one column and team IDs in another column, and we need a way to keep everything consistent. Next, we filter the database down to include only games that have everything we need to learn from them. We do this because if columns like the spread or total are missing, then we cannot use that game as an example for training. And we define the target we are trying to predict. For every game, we create a label called home win that is 1 if the home team scored more points than the away team and 0 if the away team won. This gives the model a clear answer key for each historical game. Now we're building the most important feature, a spread that is always from the home team's point of view. Of course, sometimes the betting favorite is actually the away team, which makes the raw spread confusing if we're always focused on the home team. To make the spread consistent, we first check whether the home team is the favorite, and then we rewrite the spread so it's always from the home team's perspective. After this step, a negative number always means the home team is favored, and a positive number means the home team is considered the underdog. Because the away team being favored by 7 points is the same thing as the home team being a 7-point underdog. Now we choose the inputs for the model, and we're only using things that we know before the game starts. We use home_spread because it's a market summary of who is expected to win and by how much. We use over-underline because it describes the expected scoring environment, and that influences how games might play out and how much randomness we tend to see. We also include whether the game is a neutral site because that takes off the home field advantage, and whether it's a playoff game because we all know that playoff games tend to be more intense and tight than normal games. And we're also including the season because the league changes over time, and this lets the model adjust for different eras instead of assuming that all decades just behave the same. Next, we train our logistic regression model, and this is of course designed to output a number between 0 and 1. Logistic regression learns a weight for each number, then combines the inputs and weights into a single score, and converts that score into a probability that sits between 0 and 1 using the sigmoid function. Of course, we're also standardizing all the units before training because different columns can live on different numeric scales, and we want the model to learn feature importance based on what actually matters, not just based on the units. We are deciding to train on past seasons and test on current or future seasons, and this is the way that chronologically makes sense, because we're always trying to predict the future using the past. Finally, we build a small helper function that takes a single game's inputs and returns the model's probability that the home team will win. The function works by constructing a one-row table with the exact same features the model was trained on, and then calling predict_proba, which returns the win probability for the home team. And now we can finally run this model on our playoff game that's happening tonight between the 49ers and the Seahawks. So we use our helper function, and the model predicts that, drumroll please, the Seattle Seahawks will win with 61% certainty. And that is a full logistic regression classifier for you coded out in Python, so don't forget to save this video so you can come back to it after the game tonight and follow for more. See you in the next one.